about the local variable type inference and what it provides for us. What we can do here is focus on focus on a few more features. Switch expressions. Switch as an expression rather than being a statement. Now, one aha moment I had in my learning is that functional programming languages don't have statements, because functional programming languages want to be formed of expressions, so they prefer expressions over statements. And that blew my mind, to wake up one morning and realize that there are languages which have no statements at all is absolutely intriguing. And to say, gosh, this is really amazing, you're building this entire set of things with expressions rather than statements. So in that regard, statements force mutation. Because if you call a statement, the statement performs an action, but it doesn't return any result to you. You go to a statement and say, hey, statement, can you do this for me, please? It says, sure, I did it. What's the result? I won't tell you. Go get it for yourself. That's what a statement is doing, isn't it? So by their nature, statements force mutation. Expressions, on the other hand, return a result, and they don't force mutation on you. And when we use expressions, it becomes a lot easier to build our applications with it. So let's take a look at how we could use expressions in here. So I'm going to call a function called process, pass a 1 to it, call a function called process, let's say pass a 5 to it, and call process and pass, let's say, 8. So I'm just passing some data. But I can write the function public static, let's say, string, and I'm going to call the process function to take a number as an argument in here. Now, in this case, of course, I'm going to just output the value that we have received from this function at this point. Now, when you look at this code, what does the process return, after all, to the caller? So we want to return a result of some sort. Whatever that result is, we want to be able to return it, isn't it? But the way I'm going to implement this function is to write a return, but a switch and number. So notice, switch is an expression here rather than being a statement. In the past, switch was a statement, which means in the case blocks, you'll be mutating variables. And that increases noise, it increases error in the code, and it increases the verbosity of the code as well. On the other hand here, you can simply say case 1, and I can simply return got 1, for example. And then I can say case, let's say, 2, 3, and 5, and I can simply return got a prime, for example, right? And then you can say over here, case everything else, default, and I could simply say, in this case, what do I want to return? Default, and I can simply say, something else. So essentially, you can write the code very fluently by using a switch as an expression rather than using it as a statement. So what does this do for us? It reduces the verbosity in the code, as I mentioned earlier, and also makes the code less error-prone because you're not creating unnecessary mutable variable. And anytime we create fewer mutable variables is actually a better thing to do in general, so that is something we should definitely favor as much as we actually can. So that's basically what we are seeing here, is to be able to write code like that and be able to do this. Ignore the warnings because it's still a preview feature, but in the bottom notice it says got 1, got a prime, something else, and that's a result you got from this call. But not only can you do this, you can write this as a little bit differently. If you want to do some work, you can do some work and then you can yield, and yield is a new keyword. And using yield, you can return back the result on that particular segment. So in this case, maybe you want to do some work within the case block. You can do that work, and then when you're done with it, you can simply say, I want to yield over here this particular got prime, and then finally I can just yield over here instead of this arrow. I can yield some result here as well, and then you can return that in your code. So when you run the code, as you can see in the bottom, it gives you that result, as you can see. That's another way to write it. So that becomes a nice little switch expression. Now, the switch is exciting as an expression already. This is another thing I really like what they're doing. They didn't say, we want to bake something and release it in one shot. They realized that this is what they want to create, but there are intermediate things they can create that is still useful, and they can let us use it, and at the same time they can get feedback on how good it is or how bad it is, and that's the reason why they start releasing this early. But a switch is actually a pathway to something even better, which is pattern matching. We'll talk about this in a few minutes. So that's an example of what you can do in switch. Similarly, a text block. So what is a text block? Well, we all have written code like this at some point, isn't it? You say string message is equal to, and then what do you do here? We say this is a message. And then you realize there is more to type. Then you say message plus equal to, written here on this day. And then you write, one more line, message plus equal to. And then this is really something we are never proud about. You write this kind of code, that's the lowest point in programming, isn't it? And you write this, and you never want anyone to see this. And this is what you hide from others seeing, isn't it? And that is one thing to be careful about. Eddie showed this picture earlier of a programmer with the baby on the lap. That's one thing, I mentioned this earlier today, but I'll mention it again. I really wish adults warned me about it when I was a young person. My children were very small, and I used to put them on my lap, and then I would code. And when I'm coding, facing the computer, they would just keep banging on the keyboard, while they would give me the new variables of my choice, and then I would keep writing the code. This worked really nicely for a while, until one day, the kids are becoming older and older, and one day the kid kind of turns and looks at me and says, "Dad, that's what you do?" And slips away from my lap and runs over to his mom and says, "I'm not going to sit on Dad's lap anymore. I saw the code he was writing." I am the last programmer in my family, and I have to sadly say that. I go to my children, and they look at me and say, "Dad, when we grow up, we'll make the money and support you. You don't have to do the coding you do." And that's what happens, right? When they see the verbose code you write, they have empathy, and they say, "You don't have to do this." But you know what? I love the programming for most of the part. It can be a lot better. So what we can do here is use a text blocks. So you can say this is a message, for example, and we can remove all this noise in the code that you see up here. And what we can do is we can say, for example, this is a message. All right, and then written here on this day, on this, let's say, wonderful day, and of course in Amsterdam, and we can keep going. And in this case, of course, you can simply write as much as you want to, and you can close it eventually, and you can get the results out of it. So what does this really provide for us? It provides for us the ability, of course, you still need the semicolon, and this is one of the problems. If you write code in multiple languages, you end up being good in none of them. You also know that you really hit the low point when you argue with the compiler. Like, for example, the other day, I wrote the code without the semicolon. And Java said, "You're missing a semicolon." And I was like, "I'm not missing it, you see." So this is not helpful at all. So the point really is, you really have to kind of put that in there. So the point is, when you write this code, you can see that you can write the multi-line strings, and essentially it kind of gives us a warning saying it's a preview feature, but that's exactly what we are doing here, is that it's a text block that you can create as well. So with that said, Java is really interested in minimizing boilerplated code, because when we have, good point, I saw somebody mention that there. It is very smart, as you can see, thank you. So it's a smart thing. You can see that it actually removes the indentation in the beginning. That's a smart removal of indentation. But if you put a tab in there, it sensibly realizes that you really need the tab for that and preserves the tab over there, but it removed the tab on those sides. So, I'm sure you realize this also, right? These are the little things you get really excited as a programmer. I mean, you look at this and like, "Oh my gosh, this is amazing." And people around you are like, "Why are you so weird?" And you're like, "Let me show you," right? This doesn't help you in general. But the point really is that this is very smart. It's being sensible. And you feel like the language is in with you, right? You're walking intelligently. That's a nice little add-on. So kudos to them for doing that. So given this, of course, Java is really getting towards removing ceremonies. Now, one of the things we do in Java is we have this passion for writing a lot of useless code. And of course, over the time, developers figured out a great way. This is the funny part, right? The first initial developers sit there and kept writing code that Java wanted. And then people realize, it's boring to write all this code that you have to write for Java. It's way better to create IDEs that vomit that code. So they decided to instead create IDEs. I mean, this is the beauty of programmers, right? We don't do real work. We do meta work because it's so much more fun to do meta work than do real work. And they're like, what are you doing? I'm creating a little tool to automate to create that stuff. And why are you creating that stuff? Well, because the language wants me to create it, right? So we spend time on spinning all of these things. And what if we don't have to write it? Now, typically, what do we normally do when we create classes? We create a class, first of all. And are we done? No. We create a constructor, right? And we create a constructor. And then what do? Then you create a field, if you will. And then, of course, you create properties for the field. And then what do? Write a toString method. Are we done? Oh, no. You write an equals method. And then wait for somebody to tell you you're wrong. You should also write a hash code method because you forgot to write that. And by the time you're done with this, your boss is like, how's it going, right? And you're like, shut up. I have to just make sure that everything is there for Java to work. And this is a lot of boilerplated code we have to write, isn't it? Now, the question is, what is special about a lot of this code? And the scary part about this is, it is not special at all, and that's why we have IDEs that spit this code for us. Now, there are two problems with IDEs spitting code. The first problem is you need an IDE. And second problem, you're always complaining about your IDE versus my IDE. And this is never ending. I mean, if you ever want to start a bar fight in the bar, just announce that one IDE sucks. And fight erupts in the room, isn't it? I mean, nothing makes programmers as angry as telling their IDE sucks. And, it's kind of nice to kind of start this and watch. That was an eclipse one day, right? Everybody's enjoying eclipse. And I'm like, what can I do to stir up this? So all I said, eclipse is not the only IDE you know. And that's all I did. This has nothing to do with the real eclipse. People forgot about watching the sky. Now they are fighting. This IDE is better than other. It's like, gosh, the word eclipse. And people just want to relate to this, and it's like IDE, they want to fight over it. But that's the fun part. But the second problem with this is, when you have an IDE vomit all that code, you still have to live with that vomit every day. And every day you modify the code, you got to come and change the code as well. So what is the right thing to do? Well, the right thing to do is where a language does all this for you, and it's not a violation of drive principle. Your code becomes easier to maintain. Your code becomes easier to read as well because you got less things to read. So what can we do about this? Well, this is where Java is working on, the Java developers are working on a record class. So what is a record class? Let me give you an example of what a record is going to look like. So I'm here in Kotlin, just to give you an example. I'm going to say class person. And I'm going to say over here, val, let's say first name, we'll say in this case is a string. And let's say last name, well, last name is a string as well. So we'll just create this part right here. So that's a person we defined up here. Now what do I want to do? I'm going to say val, let's say Alan equal to a person, and we will say Alan, comma, let's say Turing. And then, of course, I'm going to say output Alan. When I run this code, it gives us something not so exciting. And then, of course, I'm going to create another Alan. So I'm going to say this is Alan 2. And I want to ask the question, is Alan is equal to Alan 2? And it says false because they're not equal, which is not true. They actually are equal by value, isn't it? So notice what I can do here. All I do is walk up to this class and say data. I just added that one little word. And the minute I added that, notice the output is different, isn't it? It says the person is first name Alan, last name is Turing. You got a two-string method as a bonus. You also notice it's not a false, it's a true. Why? Because an equals method was written. So in the case of Kotlin, what they do is you buy a data class, you get 5 things for free. And that's the beautiful thing, right? We all love getting buy one, get one free. But this one, buy one, get 5 free. So what do you get? You got a two-string method. You got an equals method. You have a hash code as a bonus. And then, of course, you also have a copy method given to you as a bonus. You can make a copy of an object. Well, it's immutable. You can make a copy much more easily if you really wanted to. And then the 5th one is a beautiful destructuring capability. So what does destructuring capability do? You can simply say, for example, val and let's say first comma last over here. And equal to, and you can say Alan. And then you can print the first as a variable out, so you can destructure the object very easily. And the destructuring comes almost for free because you made it a data class. So you get a buy one, get 5 free offer. And this is kind of where Java is heading. So in the case of Java, your record classes will have a lot of things, boilerplated code written for you, so you don't need an IDE to vomit that code. The compiler will generate those behind the scenes for you, and we can peacefully write the code and go home. So that's one thing that you get. But not only do you get this facility with a data class, this can become very powerful for destructuring, and that can become very powerful in extracting the data in pattern matching as well. And imagine that you can do pattern matching to extract data with almost no effort. And that is something you can do pretty nicely with record classes. And that becomes a feasibility in the future. Then comes along a sealed class. Now, what in the world is a sealed class? You probably work in a domain where you want to create an abstraction. Now, when you create an abstraction, an abstract base class can have 0 instances. Hey, what about a singleton? A singleton can have 1 instance or a few different instances. But both abstract classes and singleton focus on the number of instances at that point, given that abstract class can also serve as a base class. However, what if you create an abstraction? You create a class, but that's a class that is so special, you don't want others to inherit from that class. Oh, I can mark my class as final. You say, no, I don't want others to inherit from my class, but I want to inherit from it. So in other words, you want a privileged inheritance, but you don't want other people to inherit from your class. And in other words, these are called as algebraic data types. Algebraic data types are, again, these are things in computer science. I'll deviate for a second and mention this to you. I remember as a young programmer, I was thirsty to learn about computer science. And I remember spending the hard days of my youth and sitting, by the window, looking out through the window. I would read a page from a computer science book, and I would say to myself, wow, this concept is amazing. I wish I can actually program this. And these were theory of computing, but I couldn't program this. Part of the reason was these features were available in esoteric languages back then. And either you have to work on a big company or be in a privileged environment to be able to get access to it. And then in the next 30 years, I am watching all those ideas of computer science becoming available in mainstream languages. And that's my aha moment. I'm like, oh my gosh, I've read about this 30 years ago, but I can use it finally now. And one of them is this algebraic data types is you want to create a class, but you want to be able to inherit from it only for a specific number of classes. So how do we go about doing exactly that? So to understand this, let's play with a little example here, just to entertain this thought. I'm going to say over here, let's call this as, let's say dice.kt. So what is a dice? I'm going to create a class called dice, And what does the class dice do? It is going to represent a dice that I'm going to throw. But maybe there are some specific types of dice I want to create. So I'm going to say sealed class dice over here. Now I can create a class, maybe I can call it as 1. And what does 1 do? It inherits from dice maybe. And I can create that class, if you will. And similarly, I could create another class called, let's say, 6, which is going to be a dice as well. You can create these kinds of classes if you really wanted to. So what I'm going to do here is I'm going to say Kotlin, let's say C JVM, and compile this down to the JVM-D classes. And then I'm going to take the dice.kt, and I'm going to compile that piece of code. And notice it compiled with no errors, right? Now, in this case, I'm going to say, dice2.kt. And I'm going to create a class called foo just to illustrate the point that I'm able to actually do that. So star.kt, and I'm compiling both of those classes, not a problem. But in here, I say class, my class inherits from dice. And I'm inheriting from that class called dice that we created up here, as you can see right here. But when I go back to compile the code, what does it tell me? It tells me cannot access its private in dice. So in other words, this is a privileged class. It's a sealed class. And what that really means is that I cannot inherit from dice anywhere I wanted to. I can only do this within this file. And hopefully, you are the only one with permission to access that file. So the point really is you are creating a hierarchy of classes, but those classes are limited to your file, and because it's mentioned as a sealed class. And that's exactly what Java is going to do with a different syntax, obviously. And so what are the benefits? The benefit, first of all, is you create a group of abstraction, algebraic data types, and you say, this is my base class, and these are the derived classes, and nobody else in my system can have classes to inherit from it. So think of this as a privileged final, right? It's a final to everybody else, but not to you. And secondly, because the children of this class are known at compile time. Would you agree with that? Because it's known in that file. So the system can close the hierarchy. And the system says, if this is a base class, these are the only children available. Why is that important? All of a sudden, you write a pattern matching switch. You don't have to write a default, isn't it? Why don't I have to write a default? Because you put all the cases in there, and your cases cover all the classes that are children of your class. The compiler says you're done. And so the compiler is able to verify that you have handled all the possible situations. And as a result, the compiler is able to tell you that your code is complete for what you need to look for patterns. So better error checking and better optimization of your code as well. And that is a benefit you're going to get out of this particular feature. And that is essentially where the sealed classes are coming. And that leads us to pattern matching. So what is pattern matching? Pattern matching is a very powerful capability, which is something we all enjoy using in very powerful languages. What blew my mind in Erlang was pattern matching. I can write a function where the function can have multiple entry points. And the entry point that's called is based on the pattern of the data. Or you receive a particular data, and you can go through excuse me, and process the data very easily using a set of patterns. Life becomes really easy. Now, when it comes to these patterns, there are two benefits to this. One is you want to remove the verbosity of your code. Secondly, you want to perform very sensible operations on your code. And a third thing is you want the language to kind of work intelligently with you, rather than you having to do repetitively things that are obvious to you, but the compiler is not cooperative with you. Let's look at two examples of this. The first example I want to give you here is going to be in Kotlin, just to give an example of what we could possibly do in Java in the future when it comes to this. So I'm going to call process with the 1, I'm going to call process with the 15, and I'm going to call process with, let's say, a string hello. Now, how does this work? I call the process function. I'm going to take an input, which is any, and within this, I'm going to simply say that I want to take input and I want to work with it. So what do I want to do with the input? I'm going to say if the input is a 1, I'm going to simply print out 1. And if it is something else, I'm going to simply say whatever for now. So when I run the code, what it is going to tell me is 1 and whatever for those two. On the other hand, I'm going to say in, well, 13 to 19, I can simply say this is a teen, right? And I can then print out that we got a teen when you give me a number 15. So this becomes a nice way to process the data as it comes in. On the other hand, I can say is a string, and I'm going to say over here, got a string. And when I run the code, notice it says got a string. But while we are at this, let's go a little further. Of length, and I want to know what the length of the string is. But before we go further, let's switch over to Java for just a minute, if you don't mind. And in the case of Java, what I want to do here is, let's go ahead and say that I want to ask Java for something. I'm going to say public, let's say static void process. And in the case of Java, I'm going to say object input. And then what am I going to do? I am going to say over here a process, and I'm going to say hello and pass hello. Now, this is today's Java. Thankfully, this is not going to be tomorrow's Java. So there is hope here. But what am I going to do? I'm going to say if input is an instance of a string. And if it is, and I say else, and I'm going to say not a string. But if it is, I'm going to output here a string. So I'm going to just display that. When I run the code, it says a string. But this is Java. So I'm going to say of length. And then I'm going to say, what do I say here? Plus. And I'm going to say input.length. Will that work? No. What should I do? I'm going to go to this code and write some beautiful code. I'm going to put a string around it, and then I run the code. And in this case, it's a length, and I'm going to write that code around it and ask it to execute it. Oh, pardon me. I need to be very careful where I put the parenthesis, right? Over there, and then put one more around it. And of course, now that you have that, then you can say length over here. And what does Java say at this point? It says, give me more, right? So in this case, of course, this is the string we got, and that's the length. Is it a property or a method? So I'm going to ask for it. It says a length. Does anyone remember what this feature is called? Yeah, they call it casting. I call it punishment, right? and that's what you're doing. Now imagine this. Would you work with somebody like this at work? You know, you ask them, is it a string? Uh-huh. What's its length? Of what? Right? This is exactly what happened, right? Is it a string? Yes. What's its length? Of what? And it's like, you know how this feels like? It feels like spending an entire day with Dory from Finding Nemo, right? And you got to reintroduce us. Hi, I'm Dory. And it's like, okay, here we go again. Well, the point really is, this is not helping us, right? This is where the context matters. And so what if the language can be intelligent and work with it? And in fact, this is what I want to emphasize one thing. I always ask this question. Do you work for the compiler, or does the compiler work for you? And I have my doubts about this when I program in Java these days, right? Because the Java compiler is like, are you done? And you're like, can I go to lunch? No. Sit down and code. I will be going to lunch instead of you, right? And you're sitting there and typing all this code. And what are you doing? I am just pleasing the compiler. I'll share with you a story I will never forget. I was at a client work, and we were paired programming, but we had a fairly good room. And we had this very young Python programmer sitting about 3 or 4 feet away. And here we are sitting and coding. And he would be writing code in Python. And he, you know, when they hired him, he said, you know, I'm going to write code in Python. So he was writing code in Python. We were integrating into the Java code. And myself and another developer, a fairly senior developer, we're sitting and writing code. And this is what this developer would do. He would be sitting and writing code in Python, having a good time. And then once in a while, here's what he would do for relaxation. he would look at this and say, working with those types still aren't you? And we are like, shut up. And then we'll just keep coding. But of course, this is annoying until one day we heard a big thud and he was screaming. And we both like stopped our Java coding and we looked at him and said, are you okay? And he said, stupid Python. And we are like, what happened? This code ran for 2 hours and gave a syntax error. And we are like, yes. So the point really is, yes, there's a compromise here, right? I don't want to run a code for 2 hours and realize it failed because of a syntax error, but at the same time, I don't want to be writing, obvious code as well. There's got to be a balance. So what if languages can become intelligent? So notice over here, I'm going to say input.length over here, and when I run the code, it simply gives us the output. This is called a smart casting. And in the same token, though, if I go here and say input.length, the compiler yells at me and says, what are you talking about? Because the input is not a string at that point, but it is over here. So how is Java going to do this? The way Java is going to do this with pattern matching is a little bit even better. So what you're going to do in Java is, I'm kind of alluding to a Java syntax you will see. You can say string s. And then you can simply say s.length. And at that point, you will know that s is a string, which is the same as input. So you kind of get the casting in one shot rather than doing a casting explicitly after that. And that's basically what you're going to see in the pattern matching. And that can make the life really easy for us. And that's one thing. The second thing we should be able to do in Java eventually is to mix pattern matching with records. We saw records a few minutes ago, data classes, but you can mix that with powerful pattern matching. How would it feel when we do that? Well, as an example, if you will, let's take a look at a class here, and let's say this class is called a point. And a point contains, this is Scala code, by the way. So class point, and x is an integer, and let's say y is an integer as well. And I got these 2 points in here. But I'm going to mark this as a case class, which is kind of like a data class, if you will. And so what I'm going to do here is write a function, a process, and I'm going to send a new point, let's say 1 and 3 to this function. Now, what am I going to do with the process function? It takes an input which is of type, let's say input which is of type any, and what am I going to do with this particular code? Well, I can say in this case, input match and case, and I can say point a comma b, and then I'm going to simply say got a point. So in this code, if I try to run this particular code, what it wants to do is provide me the point in this case. And so when I run the code, it says got a point. However, this is a pretty amazing facility. I love these kinds of features. My goal is to pattern match, but my goal is to really do something with the points data. What we did here in such a beautiful, concise syntax is we extracted the A and B, which are the points in the point. So when I run the code, it says, got a point, 1, 3 automatically. And you will be able to do this in Java relatively soon. So you mix pattern matching with records, you can do destructuring of the data. So all of a sudden, you are getting the data in, and you are extracting the data with such concise code. The code once we used to write with 40 to 50 lines of code shrinks down to 1 or 2 lines of code, and the code becomes extremely expressive. And that is something we are going to see in the future, is that contraction of that pattern matching with records, very powerful, as you can see. But having said all of that, one thing that absolutely fascinates me is this idea of Project Loom. Now, in the past several years, we have been focusing on parallel computing. And parallel is important. I'm not going to say it is not important. My research was in parallel computing. I love that field. But at the same time, that just because I like it doesn't mean it's the right thing to do all the time. We need to really focus on asynchrony as much or more than parallelism. And I hate to say this, but sometimes we have to admit the truth. And that is, JavaScript got it right. And when JavaScript, when I was looking at JavaScript, JavaScript had no multi-threading. They only had asynchronous calls. And I remember shaking my head and saying, this is silly. And then you look around and you say, wow, that was a work of a genius, isn't it? Because it really makes sense to be asynchronous, and your code is single-threaded, but the execution can be asynchronous. And as a result, you remove all the problem of concurrency, and yet you are getting performance out of it. So asynchrony is extremely important. But having said that, now let's think about what threads do for us. When it comes to a thread, what do we normally do? We all have written, and we all write single-threaded application. We like single-threaded application, don't we? Why do you like a single-threaded application? It is easy to write. It is easy to understand. It is easy to explain. It is easy to debug. It is easy to maintain. Now, I have a little clue for you. How do you know you're working on a single-threaded application? It's very easy. When you work on a single-threaded application, people at work smile at each other. That's how you know, right? It's a single-threaded application. They go to lunch as a team, and you have a social, atmosphere. And then one day somebody says, hey, let's make this better in performance. And somebody brings in a thread. That's the last day there was joy in the building, right? And then what happens? You got all these threads, and you have synchronization, and you lock and deadlock, and all these mess you deal with, and it's horrible after that. But why do we bring in multiple threads? Because there is a fundamental flaw in the way that we've been doing threading. Now, if you really think about it, right, we sometimes don't realize it. But let me demonstrate to you how threading works in Java. You come to work, let's be honest about it. What's your very first line of duty at work? You come to work, you drop your stuff at your desk, and you go to get a cup of coffee, right? That's a very first routine. And once you get a cup of coffee, the next other things come to mind what you want to do. Well, you go to the coffee machine, and you find the coffee machine is empty. So what do? No, you just be there like that. Like the guy in the Buckingham Palace, right? And a colleague comes to you and says, are you okay? Don't move. Because you will not move until you get your coffee, right? Well, that's how a single thread works. Your single thread makes an I/O call, it's stuck. And so what do? Oh my gosh, my thread is stuck, what do? Create multiple threads. Why? So more threads can be stuck. There is some kind of logic here, isn't it? That I don't understand. One thread got stuck, so create more of them. So they can get stuck. What do we do when those get stuck? Create more of them. Oh gosh, we are running out of resources. Well, create a cluster of machines so they can load. And the Amazons of the world are like, keep going. Right? We are making these companies rich because they are like, this is great. You want your application to scale? We got elastic services. You're like, awesome. We are burning machines. We are screwing the environment. And we are creating more and more of these machines. Why? Because our code doesn't scale. And at some point, we look at this and say, what's wrong with this? Why are threads being stuck? Let's think about this for a minute. You have a thread, and you have a task of execution. Those two are stuck to each other. Your task says, I got work to do. And your thread says, I'll hang around and wait. And when it is finished, you move on. What if you can detach these two for a minute? Here's your thread of execution, but this is your task you want to execute. You put your task on your thread, you run it, and the task says, hey, I need some data, I need to wait for it. And the thread says, no problem, you wait, and I will come back and serve other threads and come back to you. This brings us to a concept called fibers. So what are fibers? Fibers are super lightweight threads. Now, wait a minute. Why is it a super lightweight thread? Because they told us threads are lightweight. So the word lightweight is taken. So it's got to be super lightweight, right? I mean, this is an amazing field, right? So threads are lightweight, fibers are super lightweight threads. So fibers say you don't have to be stuck. You can be executing, and when you are stuck, we'll remove the underlying thread, it can do its work and come back to you. Now the question is, how do we really make fibers work? Now, for this, we want to be able to call a method, and we want to be able to come back and execute from that call where we left. Now, there are two things that we normally deal with. One of them is really what is called as subroutines. So what is a subroutine? A subroutine is a function. You call a function, you get a result, you call a function, you get a result, you call a function, you get a result. That's a subroutine. But then what you have is what is called a coroutine. So what is a coroutine? A coroutine is a subroutine you can call, but it remembers your conversational state. Now, when it remembers a conversational state, what does that mean? You call it, and then next time you call it, it remembers that you called already and maintains a state afterwards. Let's think about this for a minute. Imagine I see you walk out the building one evening, and I ask you where you're going, and you tell me, I'm going to go finally watch that movie I've been postponing. I got a free evening, I'm going to watch the movie. So next morning, I see you, and I say, hey, did you go to the movie? You say, yes, I did. I say, how was it? And you say, how was what? Well, no, we want to have a conversational state. I ask you a question, you respond, I ask you the next question, and sometimes even months after, we may resume a conversation because we have the conversational state. So coroutines maintain conversational state. But how do they do that? How can a coroutine maintain a conversational state? Well, that comes from what are called continuations. So what's a continuation? A continuation is a data structure that captures your conversational state. So when you return from a coroutine, you return two things. By the way, no worries. This is all done by syntax sugar, so you won't even feel it. So when you make a call to a subroutine, it returns two things. It returns the data and a continuation. When you make a call to the subroutine, coroutine again, that continuation is sent back again automatically, and it resumes its state from there and continues, right? So that is one of the biggest benefits you get out of this. Let's look at an example of how this will feel like, and I'm going to give you, if you don't mind, two examples of this just to entertain this thought and see how this will be working and how this would look like and where we can go with this. So to understand this, let's take an example from JavaScript. I know that's a bit scary, but I love learning from everything possible. So let's look at JavaScript. So in the case of JavaScript, I'm going to write a function called foo right here. And this function foo, I'm going to simply say entering. That's all I'm going to do. But then I say for constant over here, and I say of foo. And I'm going to call that like it's a collection, an iterable, and I'm going to say in the loop, and I'm going to put a little $e right there. But for this to work, I'm going to mark this as a function like that. So when I run the code, it says entering, pardon me, as you can see. But then I say yield, let's say 1. It says in the loop 1. Hey, that's intriguing. Now I'm going to output right in here a little code that says step 1, and I say yield 2. And I output step 2, and I say yield 3. And then finally I say step 3, if you will. And finally I say yield 4. But when I run this code, what does it really do for us? Notice that when I execute this little code, it is telling me it's in the loop in step 1, in the loop in step 2, in the loop in step 3. This feels a little weird in the beginning. But what you noticed is that you entered the function on line number 2. But you exited the function on line number 3. Then you entered it on line 4. And then you exited on line 5. So you have multiple entry points and a multiple exit points, isn't it? So in other words, you don't enter in the beginning and exit in the end. You enter in the beginning, exit in the middle, enter in the middle, exit in the middle, and you are just going in and out of this function. So do you see the flow of logic here, right? So you are not entering in the beginning all the time. You are entering right after the yield, and you're leaving where the yield is. Excuse me. So what does this provide for us? This gives an opportunity for us to have this conversational state where you can just re-enter and re-enter and re-enter. This is JavaScript, as you know. But I'm going to switch over for just a little bit. And this is not ready for production yet, so we cannot write code with this yet. But I'm a little curious. I want to see how these things work. So I downloaded Project Loom. And this is not available in a binary format, and so I kind of got the source code. I downloaded it. And then I compiled it. And when I compiled it, it gave a lot of warnings. And I did what any sensible person will do, ignored all of that. And I just kind of ran it. It ran, I kept it. And that's what I'm going to show you here. It's not in production. I run this through a separate command so that I can just take a look at it. So let's go to the Java code right here for a second. And this is so important that it is part of the Java lang, actually. So I'm going to say over here, var scope equal to new continuation scope, and I'll just call it as scope for a minute. So we just created a continuation scope. That's all I'm doing, and I created a continuation scope. Then I'm going to say var, let's call it as continuation, is equal to new continuation, and I'm going to provide the scope to it, comma, and I'm going to just call a do work, and the do work function simply is going to take a scope as a parameter. So that's all I did so far, nothing exciting here in Java. Then what am I going to do? I'm going to import java, java.lang.continuation dot, and in this case, I'm going to say yield. Hey, that yield is coming back here again, and I'm going to do a static import on it. Then I say public static right here, a void, and this is a do work method. But what does the do work method take as a parameter? A continuation scope right here. And within here, I'm going to simply say over here, entering, as you can see. Now, in Java, you would not use continuation scope or continuation directly. Those are really for building fibers behind the scene. So what am I going to do at this point? Well, what I'm going to do here is I'm going to simply say while continuation.is done, or rather it is not done, I'm going to say over here in the loop, and then I'm going to ask continuation.run and ask it to run. Then in the code right here, I'm going to do a yield, and then yield and pass the scope to it, and I'm going to just call that one. Then I'm going to say over here, let's call it as step 1, just like we did in the JavaScript side, and I'm going to say this is step 2 after that, and I'm going to just execute that code. I want to really see how this works. So in the command prompt, I'm going to say compile loom.sh, and I'm going to compile that. And you can see the code now runs, and this is Java code running in Project Loom, and it says in the loop, entering, in the loop, step 1, in the loop, much like you saw on the JavaScript side, that is Java code executing continuations in here. Well, fibers are built on top of this. So how does it help to have fibers? Fibers are super lightweight thread, like I said. So what I can do here in the case of fiber is that I can tell the fiber, I want to create a task, an execution for you to run, and I can ask the fiber to execute it at that point. And the way to really do that is simply to create a task and then fire it off using a fiber and schedule it. And as a result, it will run, but it will not block your thread. Now, there's a bit of a catch at this point. And the catch really is that when you are using fibers, how do you tell that a fiber should not block and wait on a particular function? Well, this is what the challenge is. They're working on refactoring or reworking the functions in the JDK, so when you make a call to the function, it becomes non-blocking. And as a result, it can let go of your thread while your task is waiting. And when your task finishes, it puts a message on your queue, and your thread can go back and start processing it, and that's where the fibers really come in. So how do we benefit from such an approach? The way we benefit from such an approach is if you want to schedule a task of execution. So for example, let's say public static, let's say void, do work, and I'm going to simply say over here, output, let's say, working. So what am I going to do with this particular code? I can say here var fiber is equal to fiber.schedule, and I can take this task and I can do the do work on it and I can schedule it. And once I do, I can output called right there, and I can say fiber.join, and I can wait on that particular fiber. So let's see if it does anything interesting at this point. It says called and working. But if I go back to the working now, and if I say plus, and in this case, I'm going to say a thread dot current thread, and print out the thread of execution at this point, you will notice that in this case, it tells you it is a fiber thread, it's a shadow thread. So this is a fiber, and you have asked the fiber to do the execution for you. The benefit of this is when a fiber calls on a method to perform a blocking call, if it's programmed properly, it becomes non-blocking, and your thread continues to do other work. And all of a sudden, in your system, you can create millions of fibers, whereas you can create thousands of threads. So fibers scale enormously compared to threads, and as a result, you'll be able to do more concurrency on smaller machines. You don't need to be as elastic. And so as a result, we can scale a lot better. And you can do asynchrony in a lot better way, and that opens up door for some amazing computations. If you ask me if there is one thing, just one thing, that I'm excited the most in future of Java, don't get me wrong, I want all of that I talked about, right? But the one thing that truly excites me is Project Loom. I've been playing with this for a few years now, and I cannot wait for this to be ready. It's amazing. And I'm really looking for how we can actually benefit from that, and I think that's going to be a fun times when that actually happens. So to summarize what we talked about, Java is evolving in a reasonable pace. They are not running at a breakneck pace. They are not interested in innovating for the sake of innovating. They are really interested in innovating for the sake of staying relevant. They want to innovate so it becomes easier for the next generation of programmers to use. They want to innovate and evolve so that we can be using this for the next generation of applications that we are building. And so Java is heading in the right direction. It may not head in the speed at which you want it to head, but there's a really good reason, because Java has a lot more commitment, and they don't have the luxury of doing things and disappointing developers in the corporate world, and so the risk for Java is very high if they take the wrong step. And honestly, I used to endlessly complain about Java before the time of Java 8. And I almost quit complaining with Java 8, but with the recent changes, I'm actually a lot more in favor of what is happening in Java. And of course, my opinion doesn't matter as much, but the fact is, I can see what they are doing, and I truly like what is happening. They are putting priorities in the right place. The language is growing at the right measure. And the features that are coming in the language are really good features. Now, like I said, I program in 15 different languages. It is easy for me to just make a statement saying, my gosh, you can do this in all these other languages very easily. But that statement is naive, because I got to be realistic about the current state of Java, not in terms of the language, but in terms of the user base, in terms of the amount of financial commitment the world has on Java. And making a statement without regard to that is being economically irresponsible. And I cannot make that statement like that. So it's easy to be naive and say, I like this and like that, but the practical point is, we got businesses that rely upon this. And there is responsibilities, and in my opinion, the developers behind the Java language are being responsible while they innovate. And I think the future is pretty darn good. At least that's my optimistic mind telling me that it's going to be a really fun experience for people who have to continue to code in Java. Hope that was useful. Thank you.